Your bed. Get your bed. You don't need the balloon.
I know the math section. I got 0 and a 5 on it. But I didn't, I got hundreds on it.
And you just send me an email and I would completed and think
Then some like screenshot or anything, just like email you.
just email me and I'll look at them.
Thanks.
Okay, folks, it's that time of the day. So just a quick announcement. First of all, a couple of quick announcements. The first one is that active chemistry misbehaved on Monday. So I wasn't able to upload your homework until Tuesday. Therefore, you have through tonight to finish it if you haven't already. Number two, your next homework will be due on Sunday at 11:59 p.m. The second announcement, Ed Puzzle has acted bizarre for a couple of people, so I want to make this announcement as a whole. I can't answer why it does it, but on occasion, it will not record the grade initially, and so you got to let me know, and I go back in and change it. Now, the other thing I will say is, and I don't think it's too much of an issue from the majority of these particular videos, but I also know that if you don't finish a video, and when I say finish it, even if it's only got like a second left, if you don't let it finish running out, it will say that the video was not completed and therefore it doesn't record a grade either. So I don't know that that's the case. I'm just saying those are two instances that I've had in the past. So if for some reason that has occurred to you on the math chemistry videos, let me know and I will go back and look at your grade and when you completed them. And edit from there. Questions about those announcements? Okay, it looks like most people are here, so I'm going to go ahead and pass out the exams. And for some of you, you're getting not only this exam, but previous exams. But anyhow, I will go ahead and pass back the exams. I think that will make everything up to date on Blackboard other than those that have the questions about the Ed puzzles. So, Skylar Arnold, come up to my left when I call your name to grab your exam. Connor Biss. Hi. Ashton Casey. Lisette Childress. Sydney Chiquano. Eric Revere. Sydney Dunlap. Oh, don't worry about it. Dakia Ferris. Dakaya, I do that every time. Jordan Fetter. Destiny Grant. Harrison Hall. Lauren Hall. Michaela Hardwick. Krista Harper. Ashlyn Hebner. Jaquan Hervey. Do that every time too. Grady Johnson. Kanias Johnson. Amia Jones. Tahia Kabir. Tasia. I'm sorry, Tasia. Anna Lewis. Riley Miller. Olivia Mays. Malik. Bella Nelson. Julia Norwood. Kaylin Oswald. Rachel Peterson. Amanda Ray. Brock Riddle. Isabella Rose. Taylor Ross. Raven Selman. Mason Simpson. Lexi Sumche. Okay, so as promised today, the first thing we're going to do is I'm going to let you work some problems while I come around, and this is the material we covered on Monday. I'm going to let you work on some of these problems, and I'll walk around, and then I'll put up some more problems, and depending upon how things go, I may start new material towards the end of class. So these are the first two problems we'll be working. And I will go through them, but I want to give you time to try to practice them. I hope you want to go home. I do not, not until Monday. Well, no, yes. I do on Monday. Technically, I don't have any until after break, but I'm trying to think of my Monday schedule. Think I'll be in my office most of Monday. Can't remember what's going on. Come on, baby. Go on. This go around, I did it different than I have in the past. It can be set up one thing, but obviously I try to give you everything.
We're trying to find out how many grams of this theoretical scale. So we take this study. So basically.
Okay, so it's like brands, then one more ratio. And then all the mass, one more ratio. Yeah, it makes sense.
But I think. Yeah. Basically, yeah, it's basically just.
Okay. They're not
Yeah, so anytime I ask for the revenue or mass of product, or mass of material, yeah. you just get that. The what? Theoretical yield is going to be the mass of that material. Basically, theoretical yield is when everything gets used up. And all you have left is that product. And the other product. So this is. I think you can stickers away. I think you can stickers away. Wrong thing. You're so wrong. Guess I could figure out that information. Oh, wait. Then you go. Good girl. Here, use that as a blanket. Pillow.
It's like a
Okay, I see a lot of people looking up, so I'm gonna go ahead and go through some of these. On the first question I asked for theoretical yield, you see theoretical yield, what it means is mass. It's just another way we're gonna ask for the mass of that material. So I want to know the mass of zirconium chloride given the mass of chlorine. I have two different, so basically I'm taking that 950 grams of chlorine gas, and I am converting it into grams of zirconium chloride, zirconium 4 chloride. Because I was dealing with the mass of the chlorine, it means I'm going to need the molar mass of chlorine. Because I'm dealing with two unique substances, it meant I was going to need the mole to mole ratio. And because I was going to the mass of the zirconium chloride, it meant I was going to need the molar mass of the zirconium chloride. So that's what I have in blue directly under the problem. Now, to begin with, we're going to start with the 950 grams of chlorine. And we're going to begin this calculation. First thing I need to do is I need to eliminate grams of chlorine. So I'm going to use the molar mass of chlorine. So that 70.90 grams of chlorine is in 1 mole of chlorine. The grams were placed in the denominator so that the unit and the substance would cancel out and you would be left with moles of chlorine. Now that it's in moles of chlorine, you can convert to moles of zirconium chloride using the mole to mole ratio. There are 2 moles of chlorine for every 1 mole of zirconium 4 chloride. The moles of chlorine were placed in the denominator so that they would cancel, leaving moles of zirconium chloride. And now we can convert that moles of zirconium chloride into grams of zirconium 4 chloride using the molar mass of zirconium 4 chloride, which was 233.024 grams of zirconium 4 chloride is equal to 1 mole of zirconium 4-chloride. The mole was placed in the denominator so that it would cancel, leaving you grams of zirconium 4-chloride. Since that's what I wanted to solve for, I complete this reaction and you get 1,560 grams of zirconium 4-chloride. Questions? Yes.
For my calculations from the whole math, it's like I got to like the right concept of the number. It's like my numbers were like how you got but let's say like right there 233.025 grams. I got 233.036.
Okay, so that's actually a perfectly valid question. The difference is likely going to be the periodic table I used, because some periodic tables, like the one on my phone, only goes to 2 decimal places or 4 digits typically, whereas the ones I give you have more than that. So that little bit of difference, if it's in the hundredths, thousandths area, that's not going to make a huge difference. And it is due to the periodic table. No. On an exam, when I do work on the exams, I actually use the periodic table I give you on the exam so that I make sure our numbers should be the same. Okay, the other one was barium nitrate. We wanted to know the mass of barium nitrate. I could have just as well asked for the theoretical yield of barium nitrate, but I asked for the mass of barium nitrate that could be formed from 55 grams of barium carbonate. According to the reaction where barium carbonate reacts with 2 nitric acids to form a barium nitrate, a carbon dioxide, and a water. So what I'm working with here is I am working with 55 grams of barium carbonate, and that is being converted into grams of barium nitrate. Because I do have 2 different materials, I am going to need that mole to mole ratio, which is a 1-to-1 ratio. Because I have grams of barium carbonate, I am going to need the molar mass of barium carbonate, which comes out to be 197.3392. And because I have grams of barium nitrate, I'm going to need the molar mass of barium nitrate, which is 261.3404. To start this problem, I will start with the 55 grams of the barium carbonate and go from there. The first conversion factor you're going to need is going to be the molar mass of barium carbonate. So that's going to be 197.3342 grams of barium carbonate is 1 mole of barium carbonate. The grams go in the denominator so that they cancel, leaving moles for the numerator. The next thing you need is the mole to mole ratio. This is in a 1-to-1 ratio of barium carbonate to barium nitrate. The barium carbonate goes in the denominator so that the unit and the substance cancel, and you are left with moles of barium nitrate. Now you need to get to mass of barium nitrate. That is accomplished using barium nitrate's molar mass. 261.3404 grams of barium nitrate is equal to 1 mole of barium nitrate. And the mole portion will go in the denominator so that the unit and the substance will cancel, and you're left with your grams of barium nitrate. When you complete this calculation, you should get 73 grams of barium nitrate. Questions? You can guarantee 1 to 2 of these on the next exam. Just like you can guarantee probably 2 to 3 balancing equations on the next exam. Now, I don't remember if I told you, but I do separate the balancing chemical equations questions from the stoichiometry questions. So in other words, I will give you the balanced chemical equation for the stoichiometry questions on a test. Now on the homework, you're not getting that, but I always like on a test for you to at least be able to start out on the right track. So I keep those two types of questions separately. Questions about stoichiometry related to mass conversions. Okay, so let's look at another example then. Or let's move on to the other topic we talked about on Monday. And that is we started talking about molarity. Molarity is represented with a capital M, and it is going to be moles of solute over liters of solution. And I worked a couple of problems, and that's where we're going to pick up today. So, first question. What is the molarity of 225 milliliters of solution that contains 63 grams of sodium chloride? I'll let you start working on that, and I will get you another problem. This particular type of problem, folks, is a matter of paying attention to what you need. You need moles of solute over liters of solution. So in both cases, in both cases, you are converting grams of the solute into moles of the solute, and you're converting the volume of solution into liters of solution. You then can combine them to determine the molarity. So for this, we took the 63 grams of sodium chloride, we divided it by 58.45 grams of sodium chloride to 1 mole, which gave you 1.078 moles of sodium chloride. We we took the volume of 225 milliliters and converted it to liters, which is 0.225 liters. We then combined the 1.078 moles and divided it by the 0.225 liters to get 4.8 molar for the first one. Questions?
Are you gonna be looking for six?
On this exam, there will not be any questions dedicated to significant digits. On the next question, you're going to do the same thing. You would take that 229 grams of glucose. And you are going to convert that grams of glucose into moles of glucose using the molar mass of glucose. Giving you a mole of glucose equal to 0.669 moles of glucose. And then you also do that with the volume. It was 1,500 milliliters. There's 1,000 milliliters in a liter. So that is equal to 1.500 liters. To get the molarity, the formula is moles over liters. So you get to get the molarity, you're going to take the 0.669 moles of your glucose and divide it by the 1.500 liters of solution, and you get 0.446 molar C12H22O11. Now I wanted to, I worded this in a specific way because I want to point out one detail. I can ask, when I'm asking these questions, I can ask molarity. I can ask molar concentration, or I could ask the word concentration. They all mean the same thing. Concentration is technically broader, but for this course, they all mean the same thing. So if you see molarity, molar concentration, and concentration, assume it's all the same thing, and that's molarity. Questions? Now that you've had a chance to work on a couple of these problems, how are you feeling? Not too awful? Because you'll probably have one or two of these on the next test too. Okay, so we're going to move on then to our next topic. And that topic is one that if you've had a biology course, you may have already encountered, and that is dilutions. How many of you have seen something like C1V1 equals C2V2? That is nothing but a dilution equation. Now, what this is telling us is C, though, is any concentration unit, and there are a variety out there. So the C can be any concentration unit. Instead of using C, what you'll use typically in chemistry is M1V1 equals M2V2. And in this particular case, I am specifying the concentration unit as molarity. So they're the exact same. I wanted to bring this up because I knew a lot of folks have seen C1V1 equals C2V2, but you may or may not have done M1V1 equals M2V2, but they are the exact same formula. One is just, the second one is just simply more specific. It's specifying what the concentration unit is that we're working with. Now, if I take a volume in liters and I multiply it times a molarity, which is moles over liters, you will notice that the liters cancel and you are simply left with moles. This equation works. And I use EQUN for equation. This equation works because the number of moles do not change. So you have the moles at the start of the solution to the moles at the end of the solution. They don't change. And that's the reason this equation works. Now, some other information about this equation is as long as we're using the equation M1V1 equals M2V2, again, the unit of concentration will be molarity. But for the volume, you can use any volume unit as long as V1 and V2 have the same unit. In other words, I can use milliliters in this equation as long as both of them are milliliters. I could use centimeters cubed in both equations as long as both of them are centimeters cubed. Now, when I work, so the next thing I wanted to just bring up is, how do you recognize a dilution calculation? How do you know when to use this particular equation? The answer is that the starting material and the ending material are the same substance. Yes, I capitalize same because I have seen a lot of people over the years try to use this equation for everything. I've seen them try to use it for stoichiometry purposes. I've seen them try to use it for, you name it, I've seen them try to use it. But folks, it only works if the starting material and the ending material are the same. You should not use this equation for stoichiometry purposes, for balanced chemical equation purposes. So let's just look at an example. Find one. Oh, well, I'll just make up one, maybe faster. What is the new concentration of, let's go back to sodium chloride. If 125 milliliters of a 0.250 molar NaCl solution is diluted to 750 milliliters. Folks, the first thing I note is that my starting material and my ending material are the same. The next thing I realize, or that I pay attention to, is this word of that separates a volume and a concentration. When you have the word of separating a volume and concentration, it means that that volume and that concentration go together. So volume 1 is 125 milliliters. M1 is 0.250 molar. Again, those went together. And in this case, I want to know the new concentration given the new volume as 750 milliliters. So basically, I've identified what I was given in the problem and listed it out. This helps me to realize that the equation I want to use is the M1 V1 equals M2 V2. I've made sure that both of my units match, the volume and the molarity match. And because of that, this is going to wind up being a simple plug and chug equation. Now, I do tend to go ahead frequently, and I will rearrange to solve for the desired variable. So I will divide both sides through by V2. So they get M1 V1 over V2 is equal to M2. Once you do that, folks, this is definitely plug and chug. So it's 0.250 molar times 125 milliliters divided by 750 milliliters. And that will give us our new concentration. Which comes out to be 0.0417 molar NaCl. Let's look at another example. What will be the new volume if 1.25 liters of 0.331 molar KBR is diluted to a concentration of 0.0156 molar. Again, I notice that the starting material and the ending material is the same. It's all about KBR. So that tells me I'll use the M1V1 equals M2V2. I see this of, which tells me that that 1.25 liters and the 0.331 molar needs to go together. So my V1 is equal to 1.25 liters. My M1 is equal to 0.331 molar. My V2 is what I've been asked to solve for, and my M2 is 0.0156 molar. So using the equation M1V1 equals M2V2, I'm going to rearrange this to solve for V2. So it's M1V1 over M2 is going to equal V2. Plugging in, you get a 0.331 molar times 1.25 liters divided by 0.0156 molar is going to equal my new volume. And that new volume comes out to be 26.5 liters. Questions? We'll start with a couple of examples for you to work on Monday with respect to dilution calculations. And then, folks, we're going to start getting into conversions with concentration.